Do you have any problems with grooving and cut-off? For example, because of the chattering, machining can only be done at low efficiency. Chips hit the machined wall and parts are scratched. Pip is formed in cut-off. Various problems might happen in grooving and cut-off operations.
This is Takemura from Sumitomo Electric. Sumitomo's grooving tool GND series solves these problems. First, let's look at the solution for the chattering. This is a typical external turning and cut-off machining operation. For grooving and cut-off, the contact area of the cutting is wider. Therefore, cutting loads tend to be heavy and causes chattering. GND holders have simple and rich structures since the insert clamp system is monobloque. In addition, die steel, which has a high Young modulus and is hard to bend, is used as the material for the holder, so that rigidity is further improved. As you can see, GND can greatly inhibit vibrations compared to competitors' tool. Looking at the cutting edge, it can be seen that the cutting edge position of GND is very stable during machining. In the internal grooving operations like this, chattering may occur due to chips clogging inside the hole. GND internal grooving holder has an oil hole for cooling the cutting edge. In addition, it has a wide pocket for easy chip evacuation and an oil hole dedicated for chip evacuation. Thanks to these pockets and oil hole, chip can easily be evacuated. This is the actual data of vibration in internal grooving operation. Competitors' tools is unstable due to chip clogging, while the GND allows stable machining without chips being trapped. Next, solution for chip control problems. Conventional grooving tools generate chips of the same width as the groove being machined. Therefore, chip evacuation is unstable, and the chips come in contact with machined wires, resulting in scratches on the wire surface. There are 9 types of 3-dimensional chip breakers in GND series, and all cutting edges for grooving and cut-up have a concave shape at the center. This cutting edge design has the effect of bending chips. Bending the chips allows the width of chips to be thinner than the groove width so that chip can be evacuated easily. In addition, as you can see, the chip breaker can stabilize the chip curve. Looking at the cutting edge during cutting with a high-speed camera, GND type stabilize chip control, suppress chip contact with the machined wire, and reduce scratches. The MG type and ML type chip breakers support not only grooving but also outer diameter turning. With a spherical chip breaker, the ML type exhibits outstanding chip control even in low-feed outer diameter turning. With these chip breakers, several tools can be integrated into a single GND tool even when they are separated to avoid interference. Next, we solve the problem for pip formation. Improvement of sharpness is necessary to reduce the pip. Although there is trade-off between sharpness and cutting edge strength, you can select GND with 5 degrees, 10 degrees, and 15 degrees lead angles to accommodate any type machining. CF type for low cutting force machining is the most effective chip breaker for the reducing pip due to the ground front cutting edge and the minute corner radius of 0.03 mm. Although lead angle is an effective countermeasure against pip formation, With a simple cutting edge shape, chips are evacuated at an angle, resulting in scratches on the machineware surface. With the CF type, the rake angle, land width, and front cutting edge shape are designed to be asymmetric so that chips are evacuated straightly, as you can see. As you can see in this example, straightly curved chips do not scratch the machined wires as well. This characteristic asymmetric chip breaker design of GND prevents formation of pip and scratches on the machined wire. In addition to solving the problems described so far, chattering, chip control, and pip formation, GND also can be applied to machining of exuding materials used in medical and aerospace applications. Chips of exuding materials such as titanium alloys and heat resistance alloys are more difficult to control than steel. This is because the material has high tensile strength and the chip is hard to be broken. In such case, we have GND J-type holder which have two coolant holes, one on top and one on bottom of cutting edge. Internal coolant from the vicinity of the cutting edge rapidly cools chips and makes them brittle. In addition, coolant is applied between the chips and the rake face directly and promotes chip break. Compared to normal external coolant, chip control is improved even with 1 megapascal or low pressure coolant, and it is more effective with 7 megapascal or high pressure coolant. GND J-type has another advantage. Since direct coolant has an outstanding cooling effect, GND J-type enable high efficiency machining in stainless steel and heat-resistant alloys, where the temperature of the cutting edge tends to rise. This is 316 stainless steel being grooved at a cutting speed of 200 meters per minute, which is twice the typical machining conditions. External coolant causes remarkable flank wear, and plastic deformation is observed at the cutting edge because of the high cutting edge temperature. On the other hand, using GND type can greatly suppress flank wear, enabling both high efficiency machining and long tool life. How was the introduction of our GND series? GND series offer a variety of holders such as facing and Swiss machine. Inserts are also available in wide range of groove widths and grades to accommodate various machining applications. For grooving and cutoff, please try our GND series. If you need any assistance with an application, please contact Sumitomo. Thank you very much.